Hello everyone, welcome back to Foundational JavaScript. This is the first video in section 3 of the course. Today we're going to be covering if statements and conditions. So we're going to be talking about how to construct if statements in JavaScript and also the syntax and methods we'll use for constructing more complex conditions within our code. So today we're going to be making a little bit of a little function to tell us what part of the day it is. Is it evening? Is it nighttime? Is it midnight, etc. We're just going to have a little classifier that prints to the console what part of the day it is. So we're going to start by doing a little demonstration of the very basics of doing if statement. I'm just going to create a variable called it is daytime, and then I'm going to go ahead and let it is nighttime. And then I'm going to make a little if statement. Is it daytime? If it is daytime, then it is nighttime should equal false. Otherwise, it is nighttime should equal true. So to break that down for really quickly, we have the if block there just to tell the runtime that this is indeed an if statement. Then we have a little parentheses syntax around this statement, which is going to return a Boolean value because it is a conditional statement which is wrapped in these parentheses. And since this value is already a Boolean, it's just going to return this value here. So is it daytime? True, then we're going into this block. Otherwise, we're going into this block. Pretty simple stuff. If we then go ahead and console.log it is nighttime, then we will be we'll be ready to go ahead and test our code. And there we go. False. So we know it is not nighttime, and indeed that is what we'd expect because we told the program that it is daytime. All right, so now we have the very basics of how if statements are laid out and the very basics of the syntax. We're going to take this to a little more higher level on the same example. This time we're going to go ahead and give ourselves what hour of the day it is by doing a little creating a new date and then getting the hours from that. So it's going to give us just a number between 1 and 24. Or 0 and 24. And then we're going to conditionally return whether it's evening, afternoon, morning, or noon or midnight. So I'm going to start by letting a variable part of day, and this is now initiated but not initialized to a value. And then we're going to go ahead and do a really quick test. Is hour of day greater than 5? And then we're going to use this little operator here, is hour of day less than 12. So this double and here is going to represent a logical and operator. And if you were paying attention during the last video, our video on operators, this wasn't included, and I was actually saving it for this video. So we have 3 conditional operators. We have the not operator, which is going to return the inverse of whatever the condition is, or whatever the conditional statement is. Then we have the double and, which is going to create a logical and, as we have here. So we're testing 2 statements, and it's only going to return true if both of those statements are true. And then we have the or statement, which is going to do the opposite. It's going to return true if either of them are true or false, depending on how the condition is set up. So let's go ahead and, with that knowledge, build this function quickly. First of all, if this is the case, then part of day should equal morning. And now we have another little nice syntactical thing. If we can do else if. So this is an else block, meaning that it will only run if this block did not run. If this is false, then we will move on to this block. If this is true, we're going to skip through this next block. Else if hour of day is greater than 12 and the hour of day is less than or equal to 17, then we're going to return part of day as afternoon. So yeah, pretty much the same thing there. We're just throwing in an else there to clarify that we don't need to do that if it's already been determined that it is morning. And then we're going to do that again for the evening if hour of day is greater than or equal to 17 and the hour of day is less than 24. Then we're going to return that the part of day is equal to evening. And then right here at the end, I'm actually going to do a little extra block for determining if it is noon or midnight. And for that, we're going to go is hour of day equal to 12. And remember, this is a triple equals, as we covered in the operators video, because we are actually not trying to do an abstract comparison across types. We want it to be very strict to avoid bugs. And we're going to do that again for if it is midnight. And you'll remember from earlier this or operator here. So if either of these are true, we're going to enter this block. And if that is true, we're going to say that it is noon or midnight. A little bit of a contrived example, but I wanted to be able to cover the or operator as well. And then we're going to go ahead and just console log the part of day. And right now where I'm recording this, it is actually just past noon. So if we go ahead and run this, it should tell us, yes, indeed, it is noon or midnight. And today we're going to be talking about for and while loops in JavaScript, covering their syntax, covering what they're useful for, and going through a few basic conventions for using them. So one of the main reasons that a programmer might want to use a for loop is to iterate through items in an array, and then be able to address the individual items in that array and do something to them. So I have a little array written for us here. It's an array of people, which really just means it's an array of names. They are lowercase because what we're going to be doing to this array is capitalizing the first letter of the first and last names in each of these strings. So we have first name, then a space, and then the last name, all lowercase. And so to get started with actually iterating over the items in this array, we're going to construct our for loop. And there are three statements that form a for loop. You have the initialization of the iterator variable. So I'm assigning the variable I to equal 0. You have a condition to test if we should continue looping or if we've completed the loop. And then if we pass that test, we actually iterate, we increase I by 1. And so you'll see that since array indexes are 0 based, the way that this will work is it'll start at 0, meaning that it will address this first item. We will add 1, and then it will be 1, which means we will address this item. Then it will add 1 once again, at which point I will be 2, and we will address this last item. And then it will iterate once again and be 3, meaning that now it is the same as people.length, and so this code won't execute. So we will appropriately loop through the items in this array. So I have a little logic here for actually manipulating the strings to capitalize the first letter. First, we're going to use this fancy little destructuring syntax to take the name at the index that we're talking about. So people at I would be the appropriate element in this array that we're trying to address. And then we're going to split that name into an array based on this space variable, the value rather, character really. So we are going to turn the name Jason Derulo into an array with 2 items, the first of which is Jason and the second of which is Derulo. And then we're going to assign those to these 2 variables which we are initializing and assigning here with this destructuring syntax. So now we have the variable first name, which is equal to Jason, and last name, which is equal to Derulo in the case of the first element. And then I have a little line of code here which will take that first name variable and then change it to a string which starts with an uppercase version of that first character and then is concatenated with the rest of the string, which is still lowercase. So Jason will just turn into capitalized Jason. And now that we've actually updated that first name, we can do the same logic, but for the last name. And so now we have a first name variable, which is the capitalized version, and a last name variable, which is the capitalized version. And then we just take those two variables and parse them into a string using here the template literal syntax. You can kind of understand how it works just by looking at it, but essentially we're just injecting the first name, then we're putting a space between them, and then we're injecting the last name. And we are assigning the currently addressed element in this array to this new value. So then if we go ahead and actually console log the updated array, we should see that indeed we have successfully capitalized these names. So yes, you can see how we can take a for loop and use it to iterate over the values in an array or any other iterable data type. And then we are going to move on to the while loop. So the while loop is essentially the same in a lot of ways. But we're going to get rid of the logic and the sort of containedness of this for loop and instead simply check a condition. If that condition is true, then we will keep looping. And if that condition is false, we will stop looping. So we're going to quickly create our own iterator variable here, j equals 1. And then while j is less than or equal to 20, we are going to go ahead and console log the value of j as so. And then we are going to add 1 to the value of j. So you can see here how, in a way, this is sort of an equivalent loop to this one. We are iterating a certain amount of times based on an iterator variable, but we've sort of just removed the initialization and we've done the logic of iterating that variable ourselves. And if we actually go ahead and run it, we'll see that the while loop will loop 20 times as we expect. So in essence, for loops can do all of the things that while loops can do and more without being dangerous. So while loops, they can get out of hand. If you write them wrong, they will loop infinitely, which is a pretty dangerous issue, especially if your computer doesn't have much memory or you're running in a completely unrestricted environment. So in general, we go with for loops rather than writing our own iterator logic in while loops. But there may be occasional situations where you'll find that a while loop is appropriate. But yes, just stick with for loops if you can. The special methods that JavaScript includes for manipulating and consuming and iterating over arrays without the use of for loops. So here I have the code that we wrote in the last lesson. It takes an array of people's names and it capitalizes both the first and last name and parses it back into a string and then modifies that original array to capitalize that array. And I want to show you how we can use the .map function, the .map array method from JavaScript to replace this with a much more succinct, readable, and just clean overall syntax for iterating over arrays. So what we're going to do is, instead of actually using the for loop, what I'm going to do is I'm going to assign a new variable, capitalized people, to the result from the function people.map. And then what we're going to do is we need to pass the map function a callback function that it can use to run each of the elements in the array through to map that old value to the new value. So we have the old value, Jason Derulo, here, the lowercase version. And this function will take that and return the capitalized version. And then at the end of this function, we will have a new variable, capitalized people, which will be an array of the capitalized names. So we have to take the element as a parameter to our callback function, person. I'm using the arrow function syntax. And then I'm going to, as we did before, let and use the I'm going to use the destructuring syntax to assign the first name and last name variables to the result of splitting the person's name by the space in the middle. So we're going to have as before, 2-length array of Jason and Derulo. And then each item in that array, the first name and the last name, is assigned to its own variable. Then we just go ahead and do the logic for adjusting the capitalization. So for the first name, once again, just like in the for loop, we're taking the first letter, capitalizing it, and then concatenating that with the rest of the lowercase first name. And then we're doing the same thing with the last name. And now all I need to do is return the correct string, which is a string. I'm using template literal syntax here to parse the first name, this space in the middle, and the last name into the full first and last name string. And because of the way that the map function works, we don't have to directly actually use the iterator variable to figure out where we're at in the array. And also we don't have to go through the work of constructing a new array or anything like that. It's all built into the .map syntax, which is really nice. And all we do is return the right string, and it's going to construct that for us. So if I go ahead and I delete our old for loop, and then I node index.js, we see that there is actually an issue because we have not updated the console log. But if we do that once more, we'll see that indeed we have a successful outcome. We have successfully capitalized these names. And as you go through JavaScript, you will see just how often these functions can actually be used, because we are going to be working with arrays a lot of the time. And with arrays, we're going to need to process each of those individually. And these utility functions just really allow us to really quickly handle those use cases, which are so common. And so now I'm going to give you a demonstration of 2 more of these utility functions, which work quite similarly, but slightly different. First, we have the reduce function. So what the reduce function is going to do is it's going to take an accumulator variable, and it's going to modify that accumulator variable according to each element in an array. So we're going to iterate through the array, and each element of that array is going to affect this accumulator value in some way. So let's do an example to be a little more clear. So we assign a new variable, sum, equal to numbers dot reduce, and then we're going to pass reduce a callback. And that callback is going to take as parameters an accumulator, and also it's going to take the current value, so the number that we are actually dealing with for each round through the loop. And then we are going to simply return the accumulator plus the number. And so that's exactly all we have to do. We've now written a very simple function to take all the numbers in this array and return them as a sum. So if we go ahead and log the sum value now, and then I do node index.js, we will see that indeed it has summed the numbers for us and printed it to the console. So this is a super powerful tool as well. And you can see you can probably think of a few use cases where this would be quite useful. And so now there's only one more utility function to cover, and that is the filter utility method for arrays. And I think that you can kind of get a sense for exactly how this is going to work, but let's dive into it. So we're going to declare a new variable, numbers less than 10. And we're going to assign that to numbers.filter. And then we're going to pass filter a callback function, which is going to take the number as a parameter. And then all it needs to do is return a Boolean, and that Boolean will determine whether this number passes our filter or not. So all we do is we return a Boolean value, and in order to parse out a statement into a Boolean, we simply wrap it in parentheses, much like an if statement. And we're just going to say number is less than 10. And So if the number is less than 10, we return true. That means that filter perceives it as a valid element that should be added to our array. So now let's go ahead and console log numbers less than 10. And we shall see that indeed 2 is the only element from the original array which is less than 10. So you can see how these three methods come quite in handy when you are handling arrays in JavaScript, and especially when you're moving into places where you need to be using JavaScript to actually generate HTML content. This is a super powerful set of tools. Today we're going to be taking what we've learned about loops and about array methods, and we're going to be taking it to the next level and start dealing with some more complex problems using recursion. So yes, today we are going to be creating a recursive function to handle data that is a multi-dimensional array. So here I've created a multi-dimensional array, which is to say an array of arrays. Each subarray within this array represents a word and is as such an array of strings, or an array of an array of one-letter long strings of characters, really. And what we're going to do is we are going to construct these into a sentence. And the way we're going to do that is with a very simple application of loop recursion. So when I say loop recursion, what I mean is we're going to be using multiple layers of loops to iterate through the arrays of arrays and then also to iterate through the items within those arrays. Maybe that sounds a little bit abstract at first glance, but I think that once we delve into it, it'll make a little more sense. So first, I am going to do the classic, and I'm going to assign I to 0 as our iterator. I'm going to check the strings.length against that I value, and then I'm going to increment that I value. Then inside of that, we're actually going to need to do the same thing again. And this is where the recursion comes in. We need to target not the actual top level array, but we need to now be comparing j to the length of the array that is at the outer level. So we're going to look for the subarray, then take that subarray and take its length, and then we're again going to use that to iterate through the items of this subarray. And then all we have to do is, we've already initialized the variable sentence up here. I'm just going to set sentence equal to itself plus the strings, which is the array of arrays that we have, at the outer layer and then at the inner layer indexes. So you can imagine that for the first time around, we're going to be at I equals 0 and j equals 0. So it's first going to navigate to the outer index in the first subarray in this array of arrays, and then to the first item within that first array. Then it's going to go here, then it's going to go here, then it's going to go here, etc. until it reaches the end of the array, and then it's going to move on to the next array. And you can see how we can then use this to iterate through all of the items. And then in order to put a space in between each word, we're simply going to add one more little statement in the outer loop. So after each word is completed, we're going to quickly add a space to the sentence. And you'll see that really quickly we've actually managed to build a nice little function that is able to handle this multi-dimensional array. So this is quite a simple and clean way to do it, if we're being frank, but we could also do it even better using the for each function. So the for each function is another one of these array methods, but instead of doing anything fancy like spitting out a new array or reducing it to a single value, it's actually going to just iterate through and essentially act just as a for function. So we can just do strings.forEach, then we take the callback, take a val, and then we can operate on that value. And then we just do val for each, and then we take the letter, and then we go in once more. So here we have pretty much the same thing, but it's quite a bit more readable here. First of all, the for each function name very clearly states, yeah, we're for each of these strings going to do this inner function, and then for each of those, we're going to have another inner function, 2 callbacks. And then we can essentially just do the same thing. We just take the sentence, and it's going to equal the sentence plus the letter. And then again, we're just going to take the sentence at the end of every word and append a space to it. And we've essentially accomplished the same thing in a slightly simpler and in a slightly more readable way. So again, if we delete that and then run the code again, we'll see that we've successfully created an equivalent function using these for each methods. So you can see A, how multiple level recursion works, and B, how we can use for each, and also how we might potentially use the other array methods to simplify that syntax a little further. And you can start to imagine maybe the vast amount of applications that these array methods have. So thank you for watching. Thank you for sticking the whole way through section 3. I'm excited to see you in section 4, and thanks for watching. Bye.